So, in the vast expanse of the universe, this particular satellite, which is actually TESS, teases us with a particular incredible discovery. I mean, TESS, in this case, TESS stands for the Transiting Exoplanet Survey Satellite, showed us an incredible discovery of a specific exoplanet, and there are a couple of characteristics of this exoplanet. But one interesting thing about it is how the size is related to our own planet and that of another planet that is close to Earth, in this case Venus. So fascinating to see what this particular exoplanet is all about and the incredible details that this particular survey satellite is able to put forward in terms of how this exoplanet will change our understanding of size, planets, and how that might be habitable or not. So let's dive into this particular satellite and discovery and conditions here. Now this here is a collaboration with other facilities. Now in terms of location of this exoplanet, it is 40 light years away from us, and this exoplanet name is GLIESE 12b, and this is an excellent candidate in terms of exoplanet observations coming from our further understanding of this particular exoplanet using the James Webb Telescope. But looking at this TESS results here, is amazing to see what is the potential here that this particular exoplanet has for us based on its characteristics, which includes the following. Now first, let's look at the characteristics of this particular exoplanet's environment. This here is orbiting a red dwarf, and this red dwarf here shows that this exoplanet is really close to this red dwarf, and so this is an incredible characteristics where we can understand more about how exoplanets potentially might lose their atmosphere or gain the atmosphere over time based on this incredible understanding of how close this particular exoplanet is to its red dwarf star. TESS have been subjected to a lot of studies in terms of looking at different large samples of stars, and if you look at how much it says that it visualized around 10,000 stars based on the brightness changes over a month or so, and this here shows transiting exoplanets on their particular star. And so in this case here, this particular star in this part, which is the GLIESE 12, the GLIESE 12 is fascinating because it is a cool red dwarf, and this here is located at the Pisces constellation, which is around 40 light years. And so in this particular case, where we have the letter B for the exoplanet, it's most likely number 2 on its own solar system, let's put it that way. And so this here, being able to see how close this particular exoplanet is to its cold red dwarf, is really fascinating compared to our own particular solar system, where Venus is more of the number 2 and is closer to our sun, but our sun is not a red dwarf. So it's going to be interesting to see whether it's apples to apples or apples to oranges comparisons here. Now in terms of comparison between this particular cold red dwarf and our own sun, this is around 27% the size of our own sun, and in terms of the surface temperature, it is around 60% the surface temperature of our own sun. Now in terms of this particular exoplanet here, it orbits around its red dwarf star around 12.8 days, and the size is almost close to the size of Earth, but it's lower than that of Earth, but larger than Venus. Now according to this article, it gives us an approximation as to what the temperature might be in terms of the surface of this particular exoplanet, assuming there is no atmosphere, and it says that it's around 42 degrees Celsius, which is around 107 degrees Fahrenheit. So imagine if there's an atmosphere, and now you got to think about the composition of this atmosphere, whether you have greenhouse gases like carbon dioxide or methane, that could really spike that particular temperature of this particular surface of this exoplanet. That might also be one of those things where it's going to be interesting to see how high the temperature might get in terms of the content of those types of greenhouse gases compared to Earth as well. So interesting to see how Earth's surface temperature is if we have no atmosphere. I mean, now we have atmosphere with all these different gases, and some of them really impacted by the amount of activity produced by we are producing into this particular atmosphere that we have right now. It's going to be interesting to see how the true temperature surface of Earth will be with no atmosphere and before, of course, when industrialization kicked in and stuff like that. Also, it's going to be interesting to see the dark side of this particular exoplanet that is not facing the sun. What will be the surface temperature of that particular side of the exoplanet, and so on and so forth. So interesting stuff here based on this particular article for on this particular exoplanet. And so this is where James Webb will come into play, where we're going to discover the atmospheric conditions, how much of the all different types of atmospheric gases that this particular exoplanet has, and what will be the true temperature if there is, or of course there will be an atmosphere. So I think there should be an atmosphere on this particular planet. So we're going to wait for James Webb to get those information out there and what composition might be. Might this combination of this atmosphere show that it is a true site for habitability of species or to foster life? Only time will tell based on the content of the atmosphere of this exoplanet. James Webb, we're waiting for you for this. All the same, hope you found this really informative in terms of this exoplanet here and how its size and the closeness to its sun shows that this might be a great potential for more studies coming from James Webb Telescope, and also collaboration with other facilities and the TESS, which is the Transiting Exoplanet Survey Satellite device that actually produced this result right here. All the same, hope you found this really informative. Hit a comment down below, let me hear your thoughts about this. By that way, we can talk to you soon. Stay smart as always and believe in yourselves.